Good evening and welcome to this side discussion on blockchain. My name is Singh. I'm the 5-minute school at company, as well as the Starship company that enterprise develop like software products. I'm see so many of you interested in blockchain. Part of this excitement stems from my passion about blockchain, but also my belief in growing the community of participants in this space. I have been witness to the rapid development of many new technologies and developments in my lifetime, including the internet, VR, AR, additive manufacturing, AI, machine learning, and blockchain. In each case, the early adopters, innovators, and participants have reaped the rewards and have had a relative monopoly on intellectual property and experience, which has resulted in outsized gains in their wealth compared to subsequent participants. It must be recognized that in all the technologies that I've mentioned, participation has not been equitable and the resulting wealth not equitable. Women are underrepresented in the communities that build around the innovative technologies, and certain groups of women, for instance, Indigenous women, even less present. As I sit here in the city of Waterloo that is built on the land of the Six Nations of the Grand River, there's a clear underrepresentation. And I find it difficult to reconcile the vast underrepresentation of Indigenous people with the incredible amount of innovation that is occurring here. And I emphasize that something about this needs to shift. This is one of the reasons I'm passionate about blockchain, and I'm speaking about it with as many people as possible so that we can draw in and support as many participants at this still early stage. In essence, this is community building, and the builders are incredibly important at this stage. They guide, educate, and connect the community and drive it forward. They shine the spotlight on others while eschewing it themselves and do the hard work through hype cycles as interest grows and wanes to keep the community together and thriving. Today, we are joined by an incredible community builder and leader, Christine Fahey, co-founder and executive director of the Memphis technology nonprofit Blockchain 901. Her organization promotes the adoption of blockchain technology through education, collaboration, and networking opportunities in the community. She's dedicated to connecting people and ideas and has been called the glue of the Memphis blockchain scene. Christine has worked in IT system implementations for over 15 years in Fortune 500 companies, pharma, and government. She is the Memphis IEEE Local Blockchain Group Chair, member of the IEEE Blockchain and Health and Life Sciences Standards Working Group, and is a certified blockchain solutions architect. She received a master's degree in information systems from the University of Memphis and a bachelor's degree in mathematics from Temple University. Welcome, Christine. Would you like to add anything before we continue?
No, thank you very much for having me. I'm very proud to be here and want to wish everybody a happy International Women's Day. You pretty much hit everything on the head there. There's really not much more to add, but I really appreciate everyone having me here today.
Well, glad to have you here, Christine. I don't know, you were going to attend a conference last year in Toronto before the whole shutdown happened. So hopefully this is in place of it right now, that you're able to participate in the Canadian scene. And I'm very glad to have you because just so that everyone knows, Christine and I know each other from Memphis. Christine's been a community leader there, and at the research facility, we've collaborated on a few different discussions. And so I was just happy to have you participate here. And I think I'm going to start, Christine, with asking you the question of what drew you to blockchain?
Wow. Well, I was in grad school and I got home from school one night. I was doing the dishes, the kids got put to bed, and I was watching TV and I heard on Charlie Rose that they were talking about blockchain, and it just kind of interested me so much. I was thinking, I just never thought about it. That I had heard about blockchain and cryptocurrency, but I was not interested. But it was just, there seemed to be so much to learn, and it seemed like it was such a new technology that was going to really change the world. I know it sounds, a little big there, but there's just so much that can be done. And at that time, this was about in 2016. That's when everybody was like, blockchain is going to change everything in the world. Everything's going to be, connected together, and it just turned out that through the years we've been able to find out like the real power of what it can do, and it's really more powerful when you use it with other technologies. And we're really starting to find out now what can we do with it. So I was just really drawn to the decentralization piece was really interesting, and the way that it's not really a new technology, it's just several technologies put together in such a way that make it a powerful solution and ensure the trust that we didn't have before.
You've mentioned a few different points there, new, but it's not, it's a set of technologies put together. And we had this conversation before about innovation as well on, and we led into it, we didn't finish it, but how the innovation in blockchain has been so different from the other ones that I've mentioned, like AI, ML, et cetera. And what in your mind are those major differences between, let's say, machine learning and blockchain in terms of the innovation?
Well, the way that the technology was introduced to the public was very different. A lot of these other technologies like machine learning, or like even like with the internet, there had been a process where you'd gone through the university, there were standards and stuff that worked out before it got released into the public for everyone to use, like on their everyday usage, that things were set up. All this was decided. But with blockchain, with Bitcoin, which is the blockchain is the backbone of Bitcoin, it was released to the public and it was already there. So now we're making standards. We're going through all those processes, and it's kind of like a backwards introduction into the way it's been used. And it's just been really fascinating because everybody had access to use it right away. If that makes any sense, versus waiting till it was released to the public to be able to use.
I think that's one of the reasons why I consider it a major innovation. Like if we go back to the early days of the internet, like we're talking about 90s, and there was a move to try and do standards, but really it ended up being whoever released the browser with
Right.
whatever standard and was used most widely became the standard. And do we have a degree of that that's happening right now as well?
There is a lot of work on standards, and I can speak to IEEE and also ISO. All the standards groups that I'm aware of are all working together, actually, and they're doing little bits and pieces. And then within each of those organizations, they're even broken down. For IEEE, there you have health, which focus, and even within the health section, then there's like 12 subgroups in there, which focus on anything from Internet of Medical Things to security. So everyone is working on it, but there's still standards are being built, and we're still trying to find like what is the best way to do things, because with blockchain, when you have something on the chain, it's permanent. It's not like you just say, oh, we'll just go reinstall the application again. It's there's a lot more that's involved. There's a lot more with your business processes that need to be considered beforehand, and when different groups work together, everyone's going to be affected by any change. And I think once we go over what blockchain is and do the little blockchain 101, I think that might be a little more apparent what I'm talking about. So there's a lot of work on standards now, but I still think they're coming out. There's a lot of what's the best way to do things, but that's what makes it hard for it to be adopted by like big companies or a lot of people to accept that it's safe to use or to be incorporated into their business, because there is no standard specifically yet. I mean, we're working on them; they're getting there.
No, and I know the hard work that's been happening because we spoke earlier about Ramesh and how And as part of IEEE, because I think that initial conversation happened. Did it happen at ETH Memphis
Oh yeah,
in 2017? And then I saw him a year later here in Waterloo, and there was a lot of excitement about we're working on the standards, because part of the standards, I think, is also when you go through that process, especially with IEEE ISO, there's a recognition that this is real and this is important, right? And
yeah.
I think that's something that still we see, like we still see a hype cycle right now in blockchain technologies, especially on the finance side. And it's something that I spoke about as well earlier, but you started pretty much 2016, and then you went up one hype cycle and you came down. And how many hype cycles have you gone through essentially since 2016?
Well, I mean, I think this is the third one. I think the second one, I mean, if you're talking about like big hype cycles,
Yeah.
the second one was kind of, it was getting there. But I mean, the current one is very close to what we saw in 2017. I feel,
Okay.
in my opinion, yes. But there's always something going on. It's really exciting. And then we also went through crypto winter, and nobody wanted to have anything to do. It's like a big X blockchain, and crypto's bad, but I think we're getting to the part where it is getting more accepted and people are using it. And it's not just like, full blown blockchain. I mean, there's distributed ledger that it's very popular and is very powerful to be used too. So there's different pieces. We're getting a lot of the institutional interest. And I mean, there's been billions of dollars of Bitcoin in the past few months that have been bought by very large companies. And that's really fueling the interest and making it more real.
Okay. So I'm going to, at this point, I think this is a natural segue point to just go into a very short slideshow, the blockchain 101. And as we go through this, Christine, if you have anything to add, please do so.
Sure.
So at this point, we're just going to walk through a few slides with you because we want to make sure everyone's on the same page from a blockchain perspective, and giving you a very initial introduction. Of course, there are many different blockchain technologies, and they function in slightly different ways or entirely different ways, but the vast majority of them use this methodology we're about to show. I'm going to start with a very simple definition on what blockchain is. A digital database containing information such as records of financial transactions that can be simultaneously used and shared within a large, decentralized, publicly accessible network. Now, there's a lot of information to unpack there, but we're going to focus just on a few key areas. And I've highlighted those here in red. We're going to focus on database, transactions, decentralized, and network. And when we really look at these, it's actually three core ideas. The first is the decentralized network structure. So if you are familiar with blockchain or you might have heard of a miners. Core of them consists of series computer or that are operating and changing the code of the information. They're coordinating chain amongst those are in red. We call those. There's other nodes after that, and the trend has essentially come in fed to, and they all get the results resulting block or coordinating network. Now you'll notice that in the central red network, not everything is connected all that well. Christine, do you have anything to add here?
I'm sure. Now, as you can see how everything's here, the more nodes that are in your network, the more secure you're going to be in the validation of the data that's part of it, or the transactions that are in there in the ledger. Yeah, so that's why the network effects are really important. If you have 5 people in the network or 5 nodes, and 2 of them are conspiring or bad, then it versus if you have 1 million nodes, and in order to get a percentage to be greater than the amount that the threshold is for the consensus, that's what makes it more powerful. And I think you might have broken up a little bit in there. So
exactly. I'll repeat that. Just when you're generally looking at this network structure, the red nodes in the middle are the ones that are coordinating the actual contents of the network, connecting and exchanging information to essentially build the blockchain. The parlance in the blockchain world is typically they're called the miners. and they're creating the blocks, they're mining the blocks. And the blue elements are the ones that are reading the results or feeding transactions into them as well. And as Christine was saying, the larger number or greater number of red blocks or miners you have, the more robust the security of the network. And that's typically because what the blocks and the chains and which one goes next is typically done through a voting process. And so whichever network votes for the largest block is the one that actually continues and is added to the next set of the blockchain or the chain. So with that in mind, let's actually go through and talk about what a block is. So blocks are composed of transactions. And so if you start on the left-hand side here, we've got a series of transactions that are fed into the network. So for example, if they're financial records, if they're actions to perform on any sort of data, they're transactions that are added. You'll notice there's a small key as well. So each one is cryptographically signed. So typically this uses public key, private key encryption. It can use some other methodologies as well, but that essentially ensures that only you are operating on data you're authorized to do. And these are assembled by the miners, and the miners run some logic checking. They make sure you're actually allowed to do what you're allowed to do. And then when the actual miners agree, depending on the consensus mechanism there, they will actually tack on the previous block's hash and then store this as the next block. So from a simplistic perspective, that's what their miners are doing. They're collecting blocks and deciding what the next block in the chain is. And that chain is because each block refers to the previous block. So in a very simple method, as you get more chains in the network and each one's referring to the previous one, you can actually strongly see through cryptographic mechanisms that everything is signed going back and generated in a specific way. And that if you modify any block, say that you have a historical record, the hashes that are there will actually be invalid. And so you can determine that something has changed, and then that's an invalid block in the network. So there's security built in as part of that. And then finally, we're going to talk about the derived database or the state. Now, this isn't just the instant state based on the last block. You have to replay the full chain to get the state of the world or the database as it exists right now. There are, for some chains, the possibility to download a snapshot and then continue from there. But if you want to be 100% robust, you have to go back to the zero block or the genesis block of a chain and then work your way from there to what is the current world. And then you will have a guaranteed source of truth or a guaranteed database that has essentially applied all these transactions all the way through. So have I missed anything, Christine?
No, well, I did want to point out that each of the miners is creating their own block with those transactions. So what they're doing is comparing what they've put together in the block. And if they win and we're the first ones to figure out what the nonce was, then they will compare that and validate with everybody else. But they're all separately doing that in
this network, right?
Yes.
So it's an extremely important point. Yes.
Yeah, but they're each actually, it's their own copy. And then this is a way to verify that each of those copies that everybody has is the same. That what I see is what you see. And that's what all the pieces in the background are doing. But it's not like they're all working to do like one block together. It's like they're doing their own block. And then, because I think of that's a piece that through my experience with explaining this, that it's hard for that to sink in. Like when you first hear about it, you're like, oh yeah, they're right, see what they're doing, they're putting it all together. But yeah, once you see that, I really feel like a light bulb goes off, and you're like, wow, that's really interesting. And with technology today, we're actually able to have these decentralized networks through the distributed computing and be able to connect with nodes quickly enough that it's just amazing.
I think you've really highlighted that important point here is that transparency, that every miner has a copy, every node has a copy, and each miner is also working on its own block. And then there's a mechanism where they vote on it, and then globally you decide what actually comes next in this particular chain.
Yeah.
So as a review, we're looking at a network of computers that are communicating cryptographically signed transactions in a network. The miners assemble them into blocks with references to previous blocks. and then you derive a database slash state from a sequence of transactions in the block, in the blocks. But the key here, and I think exiting from this presentation now, I think the key that you've highlighted here, Christine, is that transparency and the truth that you really can confirm on your own. Right. And is that when you were talking about in 2016, when you started learning more about it, is that what drew you in?
It was, but I could just tell you, I did not, it took me a while to fully grasp what this all meant. Like, I thought I understood it. I was like, wow, this is so interesting. And I see what everybody's talking about, how this can happen. But it took a while for it to really sink in, to have that aha moment. And, but once you get down the rabbit hole, you know, it's like, I still haven't come out. You're always finding new things, but it was pretty fascinating. Like, I just did not think like that this is the way it would be happening. I was like, wow, if you can do that, there's so many other things you can do. It makes so many things possible that weren't possible before when you have like a centralized database and you don't have control. Like you can't control what's in there. Somebody else could be changing it, and regardless of what you know is in there. But now everybody's able to compare. It's the whole network. It's just very interesting.
Well, this also touches upon the previous point you made of organizations when they're going into this now. The evaluation that they need to undertake, especially when you can't change. Because as an enterprise, if you deployed right now and you needed to change your product and you needed to convert the data and everything like that, you could. There's an expense to it, but you could. Mm-hmm. When you're dealing with large systems and large shared states, such as like the Ethereum network, for example, as you've gone through some of the processes you've gone through, what would you highlight as major risks to organizations or considerations they need to make?
Well, considerations, I believe, are realizing that it's not, so blockchain isn't just a piece of software you can just get it off the shelf and install on your machine. It's really a whole revamping your business processes and figuring out how to do that in such a way where the most value comes when you're able to work with other companies or even your competitors. I mean, it's a thing called co-opetition, where competitors work together to try to find out, and this is Dale Christie from FedEx says this all the time, if you find out where it's not where you compete, but where you agree. And those points where you agree, where everybody in all the stakeholders and in your ecosystem need to know, for example, in supply chain, like where is a cog or something. It doesn't matter. You don't need any trade secrets to know, but being able to know the location of it, what stage it's in, you all share that information instead of recording it separately. Somebody can make a mistake. You can find that piece where you all agree, and that's the part that you share. So it's a lot of planning to find out where those places are or what things are like that. And then also, if you're going to be sharing a database with the world, if it's public, if it's private, with whatever groups you're sharing with, everybody needs to have like the same terminology. So whatever you name, if you say name, or somebody might say, reference number or something, or whatever, everybody needs to have that same word or whatever to mean all the same stuff. And then you have to verify that when I say like number, that might be something different than when you say number, because that field might be something different for what you use, even if it's the same type of product. But there's a lot of stuff that goes on with the planning. So it's not just like a simple, you just transfer your database over. Now, there are some tools that are out there that are people working on to try to make that easier. I know like Baseline is they have been working on that. But it's a lot of work. And so it's really going to change the way you work. You work within your business and between businesses when you have blockchain involved.
I think that's one of the interesting things you mentioned here. We had a question come in. Are there any particular challenges with deploying blockchains for small enterprises? Is the process costly? And I think you've hit on the first part, which is the evaluation process is very different, because If we look at, for example, deploying to Ethereum, Ethereum's been around for 5 years,
Yep.
maybe 5, 6 years now, 5.5, 6 years. That's still relatively early, yet we have billions of dollars, hundreds of, well, tens of billions, maybe is it hundreds, or has it reached trillions so far that are actually locked up in the network in smart contracts. So that means there is wide adoption, but does it make sense for a small enterprise? What would the evaluation process be for a small enterprise to consider blockchain?
Well, I think if you find the friction points that you have with your business, and blockchain isn't the answer to everything either. So you're gonna have to like weigh, well, what's the importance? And not everything needs to go on the blockchain. There's because it is expensive to run things through Ethereum, especially these days. But you'd have to find out if there's anybody, if you're within an ecosystem that you feel like you can benefit from shared data with other groups that you work with. If there's some tools out there like for distributed ledger that you don't really need to have a blockchain per se with in a large network, but there might be things within your that could help. That may be for a little larger organization. There's just like a lot of different pieces, but I think find out where the friction points are that you do have, and see if there's a way, if there's like a middleman that's in there that's making things more difficult, and maybe there's a, instead of having to go through that middleman to get to a certain product, maybe there's a marketplace. So you might not actually need to have your whole business revamped with blockchain, but there might be something out there already that you can tap into, like a decentralized type marketplace, or something that is using blockchain already. So I think there's a lot of different ways that it can be used.
I agree, and this is, I recall like 5, 6 years ago there was a list of should you even use blockchain technologies, and it was like a list of 17 items, and you had to say yes to every single one of them before it said yes, blockchain is the right fit. So, and you touched on this, is you have to go through the evaluation process to determine if blockchain is even the right fit, whether there's alternative ways to actually do what you want. But you also touched upon privacy there. The data you put on a blockchain network, right, and put out in a transaction is visible to everyone.
Right.
And this also, again, goes back to what you spoke about, is everyone has a shared state. Now, with that in mind, where it's visible to everyone, let's go down memory lane. Let's go to 2016, 2017. Ethereum is kind of still early stage. And I think at that point, probably the biggest thing that I was hearing about, aside from maybe CryptoKitties, which I think was around the same time, was identity and securing identity. And can you touch a little bit about your understanding of identity there, and then also I think you're going to touch on this, but if not, I'll ask you about it. So I'll let you go first.
Okay. Well, with identity, we have to make sure we get it right, because we don't want to put anything on the blockchain that eventually with quantum computing or something, and then all of a sudden everything is available. So from my understanding, I don't believe any important information, data, you can have hashes of maybe where data is stored or how to get to things, but you don't want to have that data on the blockchain. That's what and people have different opinions on how things should be, but that should be like a secured area, and you have to make sure you do all whatever you need to do to make sure that's secure. But for identity, I think blockchain is more used to verify, like for credentialing, or I know that we're talking about having blockchain based identification, and I know that there's lots of groups that are working on this. So I'm not sure of the state of all of where they're at, but it's more to verify that where the information came from is valid versus having your data out there on the internet. So just say if it could, there's all different things you could use and to verify that you're who you are, but I don't need to know all that information about you. I don't need to know what your address is. I don't need to know, how much money you make, all those types of things. That information's there, but you can use the technology to help you verify that you pass whatever you need to pass, that you're over 21, for instance, or that you are who you are, for however that once you need to set that up. And instead of having paper, it helps to ensure that the digital records are what they say they are. They're not just somebody has access or that they weren't changed. Because that's what we're talking about, like the immutability and the ability to change. So it's not the blockchain. It's like tamper resistant. So you're able to tell if the data was tampered with.
And that's one of the pieces there. I ask about that because one of the early projects that actually came about was block certs, which was certification and certificates on the blockchain, and used primarily in the education industry.
Yeah.
And even then, you could use it to prove that you had a particular credential, but the actual transaction that was signed was for a large group of people. So it wasn't just your personal transaction. Your data was part of essentially someone like a large group's, and you had to present it, but the data on the chain itself didn't reveal anything about it.
Right.
And I think that's one piece is we have to recognize, and this is when people come new to this, is there you can only place a very limited amount of data onto the blockchain itself. It's I mean Ethereum itself, which is probably one of the largest, is barely over a terabyte right now. And it's not a lot of data, but at the same time it is. Right, in different ways.
Growing too. It's going to get right.
Which then if you come back to the small enterprise, if you're having a full node locally, and a full node is basically for everyone who's listening in, is a full, it's just Christine and I chatting right now, but for anyone else who's still out there, the full node is a full copy of the blockchain transactions, right? And that state, if you're running a small enterprise, that is not going to go down in size, is it?
Right.
And so as part of your kind of your governance of this and use of this internally, you have to have some policy on how you maintain this, because if you drop the ball, does it cause it could cause a critical failure to your infrastructure, right? And your application and product.
Yeah.
Right? Okay.
But one of the good things about blockchain is that since it is just distributed, that you don't have the only copy. So that's another realm.
Yes.
Too, but then you do have a very large size.
Yeah. Well, I bring it up because typically when you're talking about security and internal setup, companies tend to try and take the least expensive path, and then also don't look at the redundancy. And yes, you do have the redundancy externally, but if you have business processes that are running internally, you need to make sure you have redundancy, and you're continually to monitor and look at the size of this system and platform. So speaking about companies, we have a question that came in of how do blockchain models protect themselves from insider threats? And then maybe we look at this from the lens of blockchain itself, and from, because we need to narrow this from the developer perspective. So for a blockchain itself, how do they protect themselves from insider threats to the chain and the consensus mechanism, for example?
Right. Well, I mean, you're for a blockchain, it's not really like an insider threat company-wise. So because it's still the whole network, or if whatever. Yes. So I'm not sure if that's what they're talking about. But then there is the aspect of, you have to keep your keys safe too. And if somebody gets your keys, it doesn't matter how safe anything else is, they can have access to everything.
Okay, so that's, I think, the more interesting conversation right now. And I am going to touch on the other one from the insider threats perspective, but let's talk about keys. So we spoke about, because I think that's an extremely important part of all of this. So can you explain the concept of keys a little bit more, especially as it comes to, as you said, security and protecting your keys?
Okay, well, So with a public blockchain, so you're going to have your public and private keys, which most of the security audience probably understands what a public and private key is. So you're going to have a private key that you're going to keep in your wallet, but you need to make sure that's safe, because if somebody else has access to your private key, then it's just like they can be you and have access to anything related to that wallet that's in there. However, there are different, if you have a centralized, like if you went through an exchange that was like centralized, just say, your keys would be there. So you don't actually own your keys. They are somebody else has them. It's like a custodial kind of wallet. But just say if you lost your password, then you would have a way to maybe get it back, or they could still have access or figure out whatever you need to do. But I'm not sure like how much you want to go into like the keys, but if you lose, if you don't have your password in blockchain for your keys, you're kind of like stuck.
Yeah. And people have lost, when you're talking about like the Bitcoin and others, they've lost probably billions of dollars.
Like you can't call out, the president of Bitcoin and say, oh, I can't find, I don't know what my password or what my keys, where they are. I don't have my 12, my seed phrase. You're on your own. So you have to take responsibility. And I think it's one of the kind of things that make it hard for people to accept if they're really not that interested in the newer technology as it is. It's like there's a lot of extra things, and that is kind of a risk. But you really need to have good practices to how do you safeguard your keys? How do you not lose them? I mean, it's just the things that aren't like everyday things, unless you're in security. This audience may be a little better than somebody else, but anyway, but I'm not sure if that really answered what the question that they were.
You did. I think because one key phrase in there is you can't just call up the president of Bitcoin, right? or Ethereum or things like this. And this is something that, to answer that question, how do blockchain models protect themselves from insider threats? And I'm going to take that to assume, how do you prevent the blockchains themselves from becoming corrupted? Is that there are core developers, software developers, who actually develop the core software. But when they release a new piece of software, it doesn't get adopted by the network unless the miners upgrade to it. So in order for that software to actually, and the chain to upgrade, you have to have a majority of the miners in the network actually upgrade. And so there's a lot more due diligence that's given to the software that's being built, with code reviews, et cetera, beta networks, alpha networks, what have you, multiple cycles to really find these bugs, report them. And then only after they're deployed, if there's trust in that new software, does the network actually adopt it over time. So I think that is a potential mechanism that protects it from insider threats, because a rogue developer can't just go in there and say, oh, I'm now going to change it so the hash of the software will allow me to give myself, whatever amount of Ethereum.
Yeah. And there are still many ways. I mean, cybersecurity audience knows, like, no matter what technology is out there, somebody's going to find a way to. What can they do to break it? But the thing that's hard about blockchain is you need like over 51% for Bitcoin. And there's the different blockchain platforms. It may require a different percentage to be able to take over the chain, and then be able to. And there's all different kinds of attacks, and to figure out like when is that possible. So I think for cybersecurity people, it's really interesting. There's a lot of really interesting security blockchain related things that you can get involved in and learn about.
Well, it comes back to the point where you mentioned that the strength of the network is the size of the network.
Right.
Because getting 51%.
It is.
Exactly, getting 51%. So let's also touch on and expand upon that a little bit on governance models. Because say that, and we spoke about in a previous conversation, public chains versus private chains, differences in governance. Do you want to talk a little bit about governance in a private organization of any sort of blockchain?
Sure. So with a private blockchain, so like the difference between public and private is who has access to the blockchain. So like public, anybody can access it, whereas private, it might be a few companies that are involved, or like a consortium of companies that are, either in like a logistics industry or health industry, and they all agree to work together. So in order to be able to have access to that network, you're usually, you vet it through whatever processes they use. But then on top of that, there's also permissioned and permissionless. So the Ethereum and Bitcoin are permissionless and they're public, so anybody can write to the network. Anybody can have access to it. You don't have to go through any, you're okay to, you could be good or bad, it doesn't matter. Whereas on a private blockchain, there's permissions, and you can also permission a public blockchain. So it could be something that everybody has access maybe to view, but they can't write, but it's still public and everybody can see it. Like maybe something in the government might be that, so that to show that they are transparent for data. So then when you have, well, and any other with the governance, I mean, it's not easy, because you have all the stakeholders that are involved. It's just to make a decision, you're all agreeing on that same piece of software. Everybody has to agree that this thing should be done a certain way. You're not just dealing with your own company internally. You have to verify that what is going to be done is what everybody else wants done. Or if you're going to change the name of a field that, or whatever you're going to be using to identify something, that everybody has to agree on the same thing. So governance is, I think, a very difficult stage, but it's important. And I think once projects started getting involved, and a lot of the private ones, to say that they finally were implementing, maybe the technology, and they were starting to use it, and they were realizing, I think, that this could be an issue. And governance is a really hot topic right now. And then there's also, okay.
Go ahead. No, go ahead. Go ahead. There's also
talk about the decentralized autonomous organizations too.
Yes. Okay.
If you want to talk about that.
Oh, of course.
But governance it's very tricky, and it's required, and you need people to be active and have a say in it. And if the earlier you get involved with the consortium, or the sooner you have a say in the way things are going to be made, instead of coming in later and then things might be built differently than you wanted it.
So in Ethereum, there's the very early on, I think, when we talk about governance, we started getting EIPs and ERCs. So essentially proposals, and then essentially adoptions of.
And then this is on the developer side. I mean,
yes,
it's the community, but that's who works on it.
Absolutely.
Right. So that's like a little different than like a business.
Do you think there's what business can learn from that, though, at the same time going through that same sort of proposal structure?
Yeah, I think they could.
So for the wider audience, what happened is that very early on, almost right from the start of the Ethereum network, developers would propose essentially designs of particular contracts and standards on GitHub, and they would receive votes, and they may eventually be adopted as a standard. There would be a feedback process essentially on this standard, and there's a very rapid development at that point. And some of those standards, actually almost all those standards we have from back then, like ERC20, which is probably one of the more famous ones, is still around, right? And all the NFT, I guess, activity that's going on right now is based off of some standards that came in those extreme early days. So given that we have had, I mean, I'm talking about early days as if from 4 years ago, which kind of still shows you how early we are in some of these products. And so given that, and we had a question, I've had a question come in, if you want to hire a professional to build a blockchain model for my process, what skills am I looking for? How would you, let's break that down from that perspective, Christine. If we're talking about a process, is it one person who would do all of that? Or how would you break that up? Essentially, if you have a process and you need a professional or professionals.
Well, I think that not only, I mean, a lot of it, depending on your company, you probably have a lot of the talent already in-house. You may need somebody to guide you along, but then there's other companies that may need to farm out having like a blockchain expert or a team. It depends. I think you have to do a lot of internal soul searching to find out what it is you want to do, but then you also need in the beginning somebody that can help you identify what it is you need to do before you just hire like a whole team to come in and do something. So I think there's a lot of prep work. And there are companies out there that do it. You may find that you'd rather join like a larger, like something that's already in existence. So it's just a lot of research that has to be done. But yeah, why don't you give a little more details? Because you know a lot more about the development side.
The development side. Yeah. And I think though what you've said there is extremely important is that at the very beginning, you need to know the scope of the project. Because as you said, you can have software developers in-house. And many times the majority of the application is not written connected to blockchain, really. There's a layer that happens that actually connects to do the data in, out, and then essentially put the event data from changing network events back into your application. So the majority of your application could be built entirely using standard technologies and methodologies. It's that interface layer you essentially need. So having a consultant at the beginning is extremely important. And then having the right team to actually build that layer.
Right.
And if you happen to find a company that does both pieces, great, they understand it. Now, there is a key to that top layer, though, the layer that actually connects to the blockchain that you should definitely send out of house. And that's the security audit, right? Were you about to think of that?
Yeah.
Okay. So the security audit I have found is typically the point where people sometimes skip on, and it always comes back to bite them, right? Would you agree with that?
Oh, 1,000%. I think it should be required. Even if you have the best programmers in your group, there's still going to be something that can get missed because they're seeing it all the time. You always need an outside and somebody that specializes in that is even better. It is a requirement, in my opinion.
Yeah, and that security audit is something that you need to factor the costs in at the beginning of the project.
Yeah.
And usually it's not, because you ask the developer for a guarantee, and the developer can give you whatever guarantee that they want, but the reality is that they're not going to have sufficient time to test it unless you're building in more security budget for that. Now, I would also say that if you wanted to hire a professional, it's highly unlikely that you're going to find all the talent in one person. Typically, you'll find it in a firm. But as I said, most of the application you're building is not blockchain specific. It's really modeled with asynchronous data storage and asynchronous transactions. So you can actually build most of that out without needing a blockchain professional, so to speak. So I think that has been an interesting part as well. I've seen over the last few years is more and more companies are looking for blockchain solutions. But I will put on my security hat right now. I will put on my black security hat right now. And I can tell you that when new applications are being deployed to the blockchain networks, there are automated systems out there, nodes essentially, that are looking for vulnerabilities.
Yeah.
And as we encounter them, we may decide to actually exploit them. And you might have a lot of cash stashed away in some of those. Now, Christine, you've done a lot of education on this piece. And how do you typically introduce someone to Ethereum programming, or sorry, Solidity programming in Ethereum? And I'm dwelling on that because it's the largest smart contract network.
Yes, and it's fairly new. You probably know more about the skills that people. I think if you have like JavaScript background, it's similar. So it wouldn't be as hard to learn. But we usually, like in our group, we usually have like an intro to Solidity class. And so are you asking like how do we introduce it to like our community, or do you mean
generally
a discussion?
Yeah, generally the group there. Yeah, generally the community group that you have is because because I usually find that you have some pretty large crowds, some pretty decent pizza as well
Yeah.
for that. But in terms of like what you've done that a lot, right? Like you've done it for a number of years now. What has worked in terms of your introduction process?
Well, I can't tell you I have a down pat, um, because we usually have a wide range of people in the audience. And that's I think with any kind of computer type class, even if you did like an analytics class or something. Um, so it's hard to find that sweet spot. But what happens is like you'll do an intro class, you start and you can kind of see like who's there, and it's kind of you figure it out on the fly how deep you can go, or you just kind of stay more basic. And then what happens in a community is you end up with people that might have already done the class before, or people that are in that class that are a little more advanced, and then they'll kind of break out in their own groups. And then there may be another type of class or workshop where maybe the more advanced people can start working together on something. So, but we usually, start with, there is Crypto Zombies is a really popular tool that people use, and you can go look it up on the internet. And but we usually have a couple. We usually started too with an intro to blockchain kind of class too. But sometimes it's so there's so much information in blockchain that it can be very overwhelming. So it's hard to find like just the right amount of time. I think it helps to have more than just one class, have something following up. We were doing a good thing for several months where our group Ken, who runs a lot of our education programs, so he was working on an app, like a game, and there was a small group of people were coming every week, and they were like talking about like how to design it. I mean, we spent like a few classes just talking about how are we going to design it, how are we going to design a blockchain type app versus the old way to do it. Like how would you, like, what are the differences? What do you have to think about? Yeah, so it's not just the programming piece; it's also the whole thing, like the state. If you're like, what does that mean? It's different things that you have to think about, and you can't just program everything the same way you would do for a centralized application. Yeah, so I don't know. So how do you deal with it? Because I know you actually have like created classes and the content and everything for Ethereum or for Solidity.
Yeah, Solidity and Viper and a few others. Well, Viper is interesting as well, but it's still new, very new. But I think you've actually touched upon a couple of different important points there. One, before I forget, check out Crypto Zombies as an intro course. It is actually pretty good in introducing the concepts. What I've found is, especially in the skill set of people coming in, if they're coming from JavaScript is the lack of systems programming knowledge really hurts. Like when we talk about a lot of things in the concept, and there's not a lot of them, but understanding state, changing of state, signatures, who's signing it, there's a lot of very fundamental computer sciencey type concepts where if you came from a background, if I'm just going to write some code, I'm going to hack around without understanding underlying systems, you struggle. You really struggle. When you actually have people who have a CS background and who have done CS not from like gone to a boot camp or something, but have gone and done CS where they've looked at the theoretical aspects, they've thought about distributed systems, they've learned about concurrency, they've learned about locking. When you talk about blockchain technologies, it kind of feels just like, yeah, okay, I understand that. That's fine. What's the point, right? Like, it's very old hat, and that's also because this distributed systems are pretty old. Like we've spoken about them for a long time. It's just the internet enabled, and I'd say the modern internet enabled the connectivity that allowed you to actually have, digital currencies, smart contracts, and things like that. So when we're trying to teach, one of the things that we have to get people, and we tell people they need to do this when you come into some of our courses, for example, the ones that we deliver with the FedEx Institute of Technology in Memphis, is you have to know JavaScript programming. And then we spend a lot of time just explaining basics of this is how blocks work. This is how state works. And we spend a lot of time on that because if you don't understand that, you're going to have problems with security. You're going to get sloppy
Right.
down the road, and you're going to write some really bad code. And then the questions also come in: what is the standard you want? Like standard language, standard kind of mechanism. It's dependent on the chain. I would say almost every chain has its own, has some smart contract capability, right? Absolutely. Like even Bitcoin has smart contract capability. It's just not as capable as Ethereum's.
And Ethereum was built to have that capability.
Actually, from the ground up, built in Waterloo by Vitalik.
That's right.
So, well, and there was a lot of other contributors. I mean, you had a lot of other folks involved in that. It's not just Vitalik, but Waterloo definitely. So, but the primary languages there are Solidity, and that is probably the biggest one. And I even look at it, the pace of that language. It's up to version 0.83 right now. And I remember when we built our course a few years ago, it was 0.4. So there's a lot of rapid development in the language as well to make it safer.
But that's where a lot of the issues with security come, because people aren't, I don't think they're used to having things change that quickly and being in production, to say, you know, it's a whole different ball game than what they may have been used to. And they'll think, oh, I'll just use this version from, you know, ever, but they don't realize like the newer version of the software, or even updating your node. If you haven't done that, then you may be open to some hack that you're not going to be happy about.
Well, I mean, and that's the key as well, is when we're talking about network security, and this is, I think, for the cybersecurity professionals, you have to understand as well that if you don't secure your node, you're probably going to have a fairly significant loss of revenue or funds. Because I recall, was it some of the first versions of the node software had, like, people didn't change the standard password because they tried to make it so easy. And what would happen is that we'd go around and again, I don't want to say who we are or whether we actually did anything on this, but we were going around and we were scanning. We were scanning the general internet to try and find these nodes that were running. And if they had the default password, you could drain their wallets, you could drain their funds, because part of that was running these transactions. Now, fortunately, when you go through setup nowadays, it's a bit more robust, but you had to update your software, right? So actually on that, I'm going to ask you a very particular question as well. Do you believe the code is law?
The code?
The code is law. So a contract on there.
Oh, the code is law. Okay, sorry.
Yes.
I think you said that's law. Huh. That's a tricky question. All
right. So while you're thinking about that, what I mean by code is law is typically when you deploy smart contract onto the network, it's in a fixed state. And there is a very large conversation on what third parties should be allowed to do or should do with that. And I'll let you expand upon that a little bit more, Christine.
Well, I let's see. I am not 100% code is law. I understand what it means, but I think you better, if you're going to be doing your code, you better make sure that you know what it's doing, because it basically is, that's how it's going to be enacted. It's going to be acting as if it's law. But I don't know if
you're hedging your bets.
It's like a philosophical kind of question, I think.
It is, and I kind of put you on the spot there, because it is very difficult to answer, because for everyone out there, the question and the problem is, and we've encountered this a lot of times in blockchain technologies, is when you deploy some code, and we're not talking about the blockchain code necessarily, but mostly about smart contract code.
Yeah.
If it has a flaw in it, is someone allowed to exploit it? And the general consensus, and this is a big battle, because this means that if you deploy something from a security perspective, you can't rely on people's goodwill to not exploit it, because you can, in a pseudo-anonymous, or in many cases a completely anonymous manner, exploit that contract and maliciously drain it of any funds that may have been collected in it, or render it inoperable. And this is why we come back to that security component is ethically, it feels like we shouldn't exploit these, but at the same time, shouldn't someone actually spend the time and effort on the security side, right? And so I think you've very much hedged your bets there, Christine, but I don't think it's a fair question because, well, I guess that's on me. That's on me because I asked it.
No, I mean it's one of those things like I understand. I think there's circumstances, but then you can't just say, okay, well now we're gonna change things. You know, it's a slippery slope, and if you do that, when is that ever going to stop? Then you totally lose the whole idea of what is decentralization. You know,
but then that does lead credence to private chains being more preferable by organizations.
Oh yeah, and I think it's safer. It's probably less of a risk for them. I think that's the way they say. Again, their risk like strategy or management that they're looking at. They do have more control. I mean, they still have to have, but that's where the governance comes in. And but in the whole decentralized network, I mean, it can be scary. You have to really know what you're doing, and that's why it really makes you realize how important it is to have those smart contracts audited.
Yep. And also the standards, right? Building off of standards.
Yes.
And I think I do want to try and, because we're running out of time here, even though later this year I'll fly down to Memphis. We'll spend a full day talking about blockchain there because I'm sure we'll run a conference as well, hopefully. But I do want to highlight a really big part of this conversation is that there is a full top-down structure that needs to exist in an organization before you adopt blockchain, consider blockchain, evaluate it, right? Like you have to have management, you have to have all these governance elements, you have to have so many technology pieces in place. And just that's in order to de-risk it.
And your data, I mean, you really have to know your data, what's in there. And I think that's another part too. Even if you have the whole plan, how you're going to get connected and update, I think a big portion is doing migrating over. And, not everybody has great data. And I think everybody knows that too, but you need some good data management practices.
Well, I thank you very much for joining me today, Christine, and joining us as well. Is there anything else you'd like to add in closing?
No, I just hope people realize that blockchain, there is a lot of different things or different pieces, but just reach out to your community. There'll be some place to go. And that's what, like for blockchain 901, we're kind of like where you can go to get your feet wet, but you don't have to, pay for like, a couple $100 to take a class and then you're not sure what things are. It's like a place to go and make connections if you're interested in something in particular. And there's meetups all over, and you can go to a meetup in basically any city, and everything's virtual now too. So there's so many blockchain and webinars like every day. I think like webinars going on in the background. Even on Clubhouse, there's all kinds of stuff going on if anybody's in Clubhouse, Twitter. Just look around and don't feel like there's too much to be able to start getting involved or start learning. You can start anywhere. There's always going to be people that know more than you, and there's always good people that know less than you. But and I know I might seem like I know some stuff, but I am by no means an expert. Things are changing every day in blockchain. That's one of the things that really drew me to it. It's so exciting. It's like there's so much stuff changing, but it's just exciting to see how things have been progressing along the years.
Thank you very much for your time, for your passion on these projects. And I do encourage everyone, despite how perhaps niche or technical this discussion has been, to reach out, check out Blockchain 901 on their website, reach out and check out other meetups, as Christine has mentioned, check out Crypto Zombies, just start investigating.
And there's lots of free ways to do it.
Lots of free, yes. Thank you very much again. Thank you for everyone. And
thanks, everyone.
Hope you have a great evening.
Bye.